Welcome to qnawire.
The escape velocity can be calculated by square root 2g M over the radius. So we know the escape speed and we know the radius of the comet. So we can get the mass of the comet by r v squared divided by 2 constant g. Plug in the number, it's going to be equal to 3.37 times 10 to the 13 kilograms. For question B, so the initial kinetic energy is the speed on the surface, half mv1 squared. The final kinetic energy is lose 90% of the initial kinetic energy. So it's only 0.1 initial kinetic energy. So the initial potential energy is on the surface is negative g capital M divided by the radius of the comet. And the final potential energy is negative g capital M divided by the distance r. And r is what we are looking for. Due to energy conservation, the initial total energy equal to the final total energy. So we plug in all this into the equation. We know the mass of the debris, and both for the debris and for the comet. We know the initial velocity, right? We know the radius of the comet. We know gravitational constant g. Only thing we don't know is the radius r. So if we plug in an equation, we can solve for the r is equal to 45 kilometers. For question 2, so the initial energy k1 plus u1. So if we express k1 equal to half mv1 squared, right? This is v1. So it's going to be half m 2gm over r and plus the potential energy. And you can find out it's equal to 0, right? So initial total energy is 0, which means the final total energy should be 0 always. Which means when k2 goes to 0, only r goes to infinite. That can make the sum of the total energy to be 0. So when r goes to infinite, this denominator in U2 becomes super large, so U2 becomes 0 too. Hence, only when r goes to infinite, the total energy here is 0.